This problem involves mixtures of solutions that contain salt to get a certain percentage of salt in a final solution. Let's take a look. How many liters of 10% salt solution should be added to 80 liters of 35% salt solution to obtain a mixture that is 30% salt solution? So what we have here is a mixture problem involving solutions that contain salt. And what you have to realize when you read a problem like this is that when you say it's 10% salt solution, that means that 10% of the solution is salt, the rest is water. And if it says 35% solution, that means that 35% of the solution is salt and the rest is water. So let's read the problem again here and see what's asked for. We want to know how many liters of 10% salt solution should be added to 80 liters that's 35% salt to obtain a mixture that's 30% salt. So we're asking how many liters of 10% salt solution should be added, so that's what we need to find. So we're going to say, let's let x equal the amount of 10% salt solution. And by that I mean, when I say let x equal the amount of 10% salt solution, I mean let x equal the number of liters of 10% salt solution. So let's draw a little diagram right here. I'm going to draw like a little beaker here, and I'm going to say that this is x liters of 10% salt solution. And I want to add that to 80 liters that is 35% solution. And that's going to end up to be, draw this one a little bigger, although these don't have to be that accurate. How many liters are going to be in the final solution? Well, this x liters plus this 80 liters, so x plus 80 liters in this solution right here. And what percent is going to be salt? 30%. Okay, so we're letting x equal the amount of 10% solution, and then I draw a little diagram kind of showing what this problem is all about. I want to take x liters that's 10% salt, add that to 80 liters that's 35% salt, and end up with a solution that's 30% salt, and I know that the number of liters must be x plus 80. So now the way we solve this problem is by looking at the amount of salt that's on the left side and the amount of salt that's on the right side, because they have to be equal to each other. Whatever amount of salt is in these two solutions right here, when we pour them together, that has to end up to be the total amount of salt that's on the other side. So let's see if we can write an equation from that. I have x liters right here that's 10% salt. Well, that means that 10% of this x liters must be salt. So the amount of salt right here is 0.10 x. Here I have 80 liters, 35% of which is salt. So the amount of salt right here must be 0.35 times 80. So 35% of this 80 liters, that must be the amount of salt that's in this solution. That has to come out to be the amount of salt that's over here. 30% of this is salt, and the number of liters of solution is x plus 80, so 0.30 times x plus 80. So it takes a little bit of getting used to look at a problem this way, but after you've solved a couple of these, I think you'll find that it's really a pretty simple process. We let x be equal to whatever's asked for in the problem. In this case, the number of liters that's 10% salt solution. And then I read the problem again. I try to draw a little diagram here that represents the situation. I'm taking x liters that's 10% salt, adding that to 80 liters that's 35% salt, and ending up with x plus 80 liters that's 30% salt. So for instance, if this comes out to be 10 liters, if x turns out to be 10 plus 80 is going to be 10 plus 80. 90 liters on one side, 90 liters on the other side. Whatever the amount of salt is over here, it has to equal the amount of salt over here. In this solution, I know 10% of it is salt. So if I multiply 0.1 times the number of liters, I have the amount of salt. This solution I know is 35% salt, so if I take 0.35, multiply times 80, I have the amount of salt there, and the same thing over on this side. Now we have an equation that represents the whole situation. All I have to do is solve the equation, and I have the solution to my problem. So let's see. Let's multiply out over here 0.10x plus 80 times 0.35. That comes out to be 28. I multiplied that on a calculator and got 28. 0.35 times 80 is 28. Now, 0.30 times x is 0.30x, and 0.30 times 80 is going to be 24. Okay, so I simplify each side as much as I can. Okay, let's take a look here and see. I'm going to add negative 0.30x to each side, so I get negative 0.20x plus 28 is equal to 24. I'll add negative 28 to both sides and get negative 0.20x is equal to negative 4. Then I'll divide both sides by negative 0.20. And I'll end up with x is equal to, let's see, 0.4 divided by 0.2 comes out to be exactly 20. So the answer to this problem is 20 liters of 10% salt solution. So it said, how many liters of 10% salt solution should we add to 80 liters that's 35% solution to end up with a solution that's exactly 30%? So if I can check this problem by looking at 20 liters that's 10%, how much salt is there? The amount of salt in 80 liters that's 35% salt, see what I get? I end up with a solution of 100 liters that's 30% salt, which is going to be 30 liters that are salt. So I can check this by looking at the amount of salt in each of these final solutions. You'll see that the amount of salt here is equal to the amount of salt here. Okay, there's a couple of different ways to solve this equation. This is just the way I did it. No matter how you solve this equation, if this is what you start with, you'll end up with x equal 20. Then we just have to remember that this is a word problem, and that 20 stands for the number of liters of 10% salt solution that we were asked to find in the first place.